Okay, good day, ladies and gentlemen. I hope you are still doing good. Today we'll be doing question 5, so called the what is a work, energy, and power, physical sciences. Ne? Okay, let's read our statement. I hope. Okay, they say a crate of 50 kg is at rest at point A. Where is our point A? This is our point A, ne? So what do you know when they say something is at rest? Its V or its velocity. Since here it is our initial, we're gonna say our initial velocity is equal to 0 meters per second. Do you get me? So then they say okay, 50 kg, this is our mass. Our mass is what? It is 50 kg. Do you get me? And then the grade of mass 50 kg is at rest at point A with is a vertical height of 5 meters above the horizontal surface. Our height is what? It is 5 meters. Do you get me? So the inclined surface makes an angle of theta with a horizontal as shown in the diagram below. This our angle of what? Angle of theta or angle of inclination. Do you get me? And then we're gonna theta is theta, okay? Okay. When the crate is released, it slides down the incline and reaches point B at the bottom of the incline with the speed of 8 meters per second. Our speed here at point B is 8 meters per second. Do you get me? The incline exerts a constant frictional force of what? Of 72 Newton on the crate while it slides from point A to point B. They are saying when the crate moves from this point to this point, the frictional force was what? F is what? Is 72. It was not changing. That's why they say a constant. Do you get me? So now we can come and answer the questions. They say what? They're saying state the work energy theorem in words. What I know about physical science, that's physical science. Every definition, okay, 80% of the definitions they come from their formulas. We know that a work energy theorem formula, it says what? It says work net is equal to what? Change in EK. Do you get me? So now let's apply the formula to get the definition. I'm gonna say what? We're gonna say the work done on an object. This the work done on an object by a what? By a net force. This is our net force. The work done on an object by a net force, do you get me? Is equal, this is our equal sign, to the change. We know that in physics, this is a change in kinetic energy of the object. Do you get me? The work done on an object by a net force is equal to the change in kinetic energy of the object. Do you get me? Let's write it. The work done on an object by a net force is equal to, excuse me, it's equal to the change, it's equal to the change in kinetic energy of the object. Do you get me? So, okay, Now we are done with the definition. Let's answer this 5.2. Okay, let's circle it. Now let's answer 5.2. They say use energy principle to calculate the angle theta. They want us to calculate what? This angle. Do you get me? So first of all, I will encourage you to do what? To first draw your free body diagram. Do you get me? Because they didn't say draw a free body diagram. So since they didn't tell you to draw it, just draw it to make your things simple. Do you get me? Let's draw our free body diagram while our object was moving from point A to point B. We know that we have our what? We have our normal. Our normal will be like this. Do you get me? This is our N. And then we have our friction. Do you get me? We have our friction. The friction always opposes the motion of the object. Since the object was moving downwards, it means that the friction is going upwards. Do you get me? So then here we have our friction. Our friction. You must make sure that your friction and your normal force make a what? A 90 degrees. Here we see that we have a 90 degrees in this point. And then we have our what? Our FG. So here is our friction. We have our FG, so-called weight or force of gravity or gravitational force. We're gonna call it what? FG. Don't write what? Don't write M. Yeah, I think we're writing weight W or MG. No, stop writing that. We're in the moderation. They say now we must consider writing what? FG. We must tell your student to write FG. Do you get me? Sorry for that. And then let's go. Now let's do what? Let's draw our component from this free body diagram. Don't worry, I will accommodate both of you guys. There are that one who draw FG perpendicular and FG parallel. I'm gonna draw I will draw that free body diagram. Do you get me? And then here will be our component. Our component. Here it will be what? FG cos theta. Do you get me? And then it will move like this. And then here it will be what? FG sine theta. And do you get me? So now let's draw the other free body diagram to accommodate both of you guys. Obvious, here we're gonna have what? We're gonna have our normal like this, our N, and then here we have our what? Our friction. This is our friction. And then here we have our what? Our FG. You call it FG parallel. FG parallel. And then here we're gonna have our what? Our FG perpendicular. Do you get me? Our FG perpendicular like this. Do you get me? But it is the same. This free body diagram and this free body diagram, it is the same. These are these components that I was drawing. You see. So okay. Since they say use any G principle to calculate the angle of theta, let's use the formula of what? Of work net is equal to what? Change in EK. Do you get me? So we know that our what? Our change in EK is equal to 1 all over 2 mv squared, the final, minus what? 1 all over 2 mv squared of initial. Do you get me? And now we are referring from point 1, from point A to point B. What is your initial velocity? We recorded it here. Our initial velocity is 0. Do you get me? And then what's your final velocity at point B? We need the velocity at point B. Our velocity at point B is 8. Let's go and substitute. And know that our mass is 50. Here we're going to say 1 all over 2 mass of 50. What's our final velocity at point B is 8 squared minus 1 all over 2 mass is 50. What's our initial velocity? It is 0 because it was stationary or it was at rest. Do you get me? First of all, let's punch this on the calculator. I'm going to say 1 all over 2 multiply by 50. I hope you are also punching your calculator. Multiply by h squared. Get what? Here we get 1600. Do you get me? 1600. So it is equal to what? It is equal to work net. Do you get me? So what is your work net? When we want to find our work net, we're gonna go to our free body diagram. Do you get me? So we're gonna say work net is equal to. Let's go to our free body diagram. We're gonna use which one? Okay, let's use this one. Work net. Since our object it is moving horizontal, it is not moving vertical. It means that FG perpendicular and normal. We won't do what? We won't consider it. Do you get me? FG perpendicular and normal force. We won't consider it because our object it is moving what? It is moving horizontal like this. It's moving between friction and what? And FG parallel. So we're gonna say, since we want work net, we're gonna say work done by this frictional force plus the work done by FG parallel. Do you get me? Let's come and write it. Work net is what? Work done by frictional force plus work done by what? FG parallel. Do you get me? So what is our work done? We're gonna say work net here is equal to what's our work done by what? By frictional force. Let's go and find our work done by frictional force first. We're gonna write it here. Work done by frictional force is equal to what? Is equal to F change in X cos of what? Cos of theta. This is the formula. This is the original formula. Do you get me? This is the original formula. And then what is your frictional force? They say our frictional force is what? It is 72. Do you get me? What is your change in X? When they say change in X, they want the distance from what? From point A to point B. And now we are not given the distance from point A to point B. But using mathematics, we can find that distance from point A to point B. Do you get me? Here is your theta. We know that in mathematics we have what? We have so, ka, to. Do you get me? So since we have our what? We have our opposite and we are looking for our hypotenuse on this triangle. What are we going to use? We're going to use this so because we have sine of opposite all over hypotenuse. And then we're going to say what? Sine. What's your opposite? Sine theta is equal to, what's your opposite? Our opposite is 5 all over hypotenuse. Our hypotenuse is AB. And then I'm going to say AB is equal to what? Is equal to 5 all over sine theta. Do you get me? So these are what? This our x. Let's come and substitute it. Here, change in x is this what? It is 5 all over what? Sine theta. What is your cos? Since your friction was going what? It is opposing the motion of an object. Do you get me? We're going to say cos 180. Friction cos 180. Cos of 180 degrees. And then when we punch a calculator here, we find that we have what? We're left with negative 360 all over what? Sine theta. Do you get me? This is our work done by what? By frictional force. Let's come and record it. Work done by frictional force is what? Negative 360 all over what? All over sine of theta. Do you get me? And then we're going to add the work done by what? By FG parallel. Now let's come here and find the work done by FG parallel. We're going to say what? Let me place, may I place right here? Work done by FG parallel is equal to force change in X cos of what? Of theta. What's your FG or what's your force? Your force is what? It is FG what? FG sine theta. We're gonna come. Someone is now confused. Our FG sine theta is this force here. it is the same as this one. This force and this dotted line here, it is the same. And then we say this one is Fg sine theta. Do you get me? That's why I'm saying Fg sine theta here. This mg5 sine theta, it is for the force. And then what's our change in x? Our change in x, it is the same as that one. It is 5 all over what? Sine theta. What's your cos? It will be cos of 0, because it is what? It is not opposing the motion of an object. Do you get me? It is not opposing. When an force is opposing when a force is opposing the motion of an object, we're gonna say what? It is cos 180. Do you get me? So okay, our Fg stand for what? We know that Fg stand for mass multiplied by gravity. What is your mass of the object? Our mass is 50 multiplied by our gravity is 9.8. Sine theta, we'll cancel this sine theta. We're gonna left with what? 5 cos 0 degrees. Do you get me? When we punch this on the calculator, we're gonna find 50 multiplied by 9.8 multiplied by 5 multiplied by cos 0, get 2450 what? Joule. Do you get me? Then we're gonna come and add it here. 2450 what? Joules. Do you get me? And then since we calculated our work net, let's substitute this work net with 1600. Do you get me? Because we found that work net is 1600 what is joules here. Do you get me? So I'm gonna say work net is 1600 is equal to what? Negative 360 all over what? Sine theta. This theta plus what? 2450. Now let's collect the light terms, because we have the light terms here. We're gonna do what? We're gonna take this 2450 to the other side. Now we're gonna have 360 all over sine of theta is equal to what? 1600 minus 2450. And then here we're gonna have let me work it out. Sine of theta is equal to negative 1600. No, 1600 minus 2450. We get what? Negative 180. Here we have negative what? 850. I mean, not 180. It's still early in the morning, guys. 4 o'clock. Oh, when I didn't sleep, that's why. I was busy studying. Okay, so here we're gonna do what? We're gonna cross multiply. Since we have 1 here, we're gonna take this one and multiply it with. So we're gonna have negative 850 sine of theta is equal to what? It's equal to negative 360, and then we're gonna divide by negative 850. We divide by negative 850. Negative will cancel negative, and then we're gonna have what? Theta is equal to arc sine what? 360 all over what? 850. And then what's our theta? Let's punch our calculator. Our theta, we're gonna get arc sine what? 360 all over 850. Okay, 25 comma what? 0. When we round it to 2 decimal places, it will be 0 what? 0.6. Do you get me? Degrees, since it is your theta. Do you get me? So and then let's do what? Let's go to our next what? Our next question. They say let's put a second letter so that we are done with it. They say after passing point B, this is our point B here, the crate slide along a rough horizontal surface. They say it slide along what? A rough horizontal surface. When they say a rough horizontal surface, we know that we have a friction on a rough horizontal surface. Coming to a rest at point C, we know that this velocity here is equal to 0 degree. 0 meters per second. I mean, you see, don't worry, guys. Just because I'm tired, but I trust myself. Even if I'm tired, I'm gonna deliver the best. Coming to point C, which is 10 meters away from what? From point B. This is our 10 meters. Now they say draw a free body diagram of all the forces acting on a crate while it slides from B to C. When the crate slides from this point to this point, you see it was sliding. There was no force that it was pushing it. You see, no force applied, I mean. Okay, our free body diagram, it means that we're gonna have our what? Our normal force as usual, because it is on the surface, and then Fg. Since it is a rough surface, we have a what? We have a friction. Friction always opposes the motion of an object. Because the object is moving from B to C, friction will move from C to B. That's why it is pointing on that air. Here's our friction. Do you get me? Now, let's go to what? To 5.4. 5.4, they say calculate the work done by a frictional force to bring a what? The crate to the rest. We want a work done. Since we know that the formula 5.4, let's answer 5.4 here. 5.4. So we know that the formula of work done, it will be work done by what? By friction is equal to what? Force change in x cos of theta. We know that cos of theta here is cos of 180. We know that our change in x is what? Is 10. Our f, let's substitute again. Work done by friction. What's our frictional force? We don't know it. It's frictional force. Change in x, the distance, they say is 10. And then it will be cos of 180 degrees. Do you get me? So, let's find out what our frictional force. Do you get me? How are we going to find our frictional force? Let's come here and see something. When the object moves from this point to this point, the only force that is acting on an object is what? It is frictional force. The only force that is acting on an object, or the only force that is affecting the motion of an object, it is a frictional force, the only horizontal force. Because at this point from B to C, the forces that will disturb the motion of an object, or that will influence the motion of an object, are horizontal force, because the object is moving horizontal. Do you get me? So it means that F net is equal to what? Is equal to F. It's equal to friction. Do you get me? F net equals to friction, because the only horizontal force here is friction. And then we know that F net is equal to what? Is equal to MA. Do you get me? So what's our M? If we find F net, we're gonna find, it means that we have found our friction. What's our mass? Our mass of the object is 50. But look here, we don't have our acceleration. They didn't tell us about our acceleration. Now you have to think, or you have to expand your mind, or your level of thinking. Do you get me? I wanna show you something. Let me come here and draw it. Here is our point B, and here is our point C. And then the distance between point B and point C is what? It is 10 meters. Here our velocity is equal to 0. And then here our velocity is equal to what? It is equal to 8. Do you get me? We know that we have a formula that says Vf squared is equal to what? V initial squared plus 2a change in x or change in y. Okay, we're going to say change in x because it is moving horizontal. What's your V final? V final is 0 squared is equal to, what's your V initial? It is 8 squared plus 2. What's your A? Your A is not 9.8. We are looking for that A. Do you get me? It is 9.8 on a vertical projectile if your object is doing what? It is moving down or upwards, and there is no force of engine, or the only force that is acting on an object is gravitational force. That's why we were saying what? Our A, it is 9.8, because the gravitational force, it is what? It is 9.8. That's why they say a motion on which the only force acting on an object is gravitational force. You know that the force of gravity is 9.8 meters per second squared. Do you get me? That's why here on A we put what? 9.8. But now the object is not moving under the influence of gravitational force, so that's why we want our acceleration. Do you get me? What's our change in x? Our distance from this point to this point, it is 10. So what are we going to do? We're gonna Here 8 squared is 64. We have negative 64 is equal to what? 28, because I say 2 multiplied by what? By 10 is 20. Then I'm going to divide by 20, divide by 20. Our A, it will be a negative 6. We're going to have what? Negative 64 all over 20. We'll find that our A is what? Negative 3.2 meters per second squared. Do you get me? And then why our acceleration is negative? Our acceleration is negative because it is opposing the motion of an object. Right now the object, it is no longer okay. It is okay when a car, let me give you a practical example. When a car, it is moving, you see a car, it is moving like this, going that side. When the driver starts to apply a brake, do you get me? When the driver starts to apply a brake, to press a brake, the car is no longer, if the car was moving with an acceleration of what? Of maybe 4 meters per second squared. Do you get me? When the driver applies a brake, the acceleration, it is no longer doing what? It's no longer going that side. It is doing what? It is going backwards. The car is now accelerating backwards when the driver applies a brake. Yeah, that's the practical example that I was giving. That's why our acceleration here is negative, because the object, you see, the acceleration, it was holding the arc. In other words, acceleration ya I come object beyibambela i-object ukuthi yewona ingahambi yakuphi ye phambili. Ngithola, sorry to use Zulu just because Zulu is a common language that everyone understands. I was about to use my home language Tsonga, but you see, since there's someone from Cape Town and for someone from India who is going to watch this video, that's why I'm not I'm not using my home language. You get me? So let's find our F net. When I say F net is equal to what? To MA. I say when we find our F net, we'll be finding our friction. We'll be finding our friction. Here we have 50. What's our A is negative 3.2. Then our F net is 50 multiplied by negative 3.2. Here we're going to have what? Negative 160 N. Do you get me? So then let's come here and substitute. Here we have our friction. We're going to have what? 160 multiplied by 10 multiplied by cos of 180. Do you get me? Here 160 multiplied by 10 multiplied by cos 180. Find that our work done by friction is negative 1600 joules. Do you get me? Okay, thank you for watching. I hope it was a great lesson to you. So don't worry, if you have something, just go, you will just send an email to me, or just send WhatsApp text on this number. Don't forget to subscribe. May God bless you and pass with distinctions. Do you get me? Thank you. Oh, let me check whether we are done with the questions here. We are done. Do you get me? Thank you.